Isosceles and equilateral triangle. Right here we've got an isosceles triangle. Isosceles triangle, two of the sides are congruent. This is your base. This is a leg. This is a leg. Okay? When I was telling you we were doing a proof on the board last week, and I said this is actually a one-step proof. This is what I was referring to. You had to prove that the two triangles were congruent. They had a line drawn right here. You had to prove that this side was congruent to this side. Well, the isosceles triangle theorem basically says if two sides, and I'm condensing and kind of writing in, I don't know, more layman's terms, if two sides are congruent in a triangle, then the opposite angles are also congruent. Now let's write this in terms of, so I'm saying if, and in this picture, what's congruent to what? Can anyone tell me the congruency statement in this picture? Anybody? What am I saying? I've marked these two, so what? Segment AB is congruent to segment what? Well, yeah, CB, yeah. Then, what do you think the isosceles triangle theorem says? What do I mean by the opposite angles? Absolutely. Then A be congruent to C. Then angle A, you have to put the angle. Angle A would be congruent to angle C. That is the isosceles triangle theorem. So basically, if two sides are congruent in a triangle, what do you know about the two opposite angles? They're also what? Congruent. Forever and ever for the rest of eternity. Okay? In any triangle. Vice versa is also true. What do you think I'm going to mean by that? If angle A is congruent to what? Angle C, then what do you think happens? What do you think I would say happens? See, here I started with these two sides are congruent, right? As a result, what happens? These two angles are congruent, right? So what I'm saying, vice versa, is, guess what? If these two angles are congruent, what do you think? These two sides have to be what? Congruent. Then AB is congruent to CB. And this would be what? The converse of the isosceles triangle theorem. That's also true. That also happens. Okay? Everybody turn your books. I don't think I'm going to be honest, I don't think I'm going to take the time to write this down because I think that it's just, I'd rather do examples than write more of this down. I think we've kind of already talked about these two, haven't we? A triangle is equilateral if and only if it's equal what? So wouldn't that make sense with that, you know, I said that if this side's congruent to this side, this angle has to be congruent to what? Well, then if you think of it from this perspective, this angle's congruent to this angle, then what? This angle's got to be congruent to what? And then, since all the angles have to add to 180, if all the sides are congruent, then all the angles have to be congruent, and they have to be what? 60, 60, 60. We're okay not writing that down, aren't we? That's something we've kind of inferred and figured out already. But that just to kind of add that they have officially, you know, there are a couple of theorems about an equilateral triangle, things that we've already figured out about them. Okay? Let's get our little handy-dandy little red books out. Okay, we've got some problems here that are just kind of testing our knowledge. What they're saying is that this length is the same as what? This length? These two are congruent, correct? In number one, name the two congruent angles then. Now, the reason this is a good problem is because, what do you guys hate about this problem? Those of you that came up and asked me questions, and a lot of the worksheets, some of you did incorrectly. You can't call this saying, I know that what's true, if this side is congruent to what? This side, would you agree? Then what angles are congruent? Angle D, I can say angle D is congruent to angle what? I cannot call that angle C. See, guys, why is that so important? Why is that a big, it is a very big deal. There's a bunch of angles on at this vertex. There's only what? One here, isn't there? Guys, this is just a reminder, because I had a lot of people, and I don't think this class asks as many questions, and when I look at your assignments from last week, which I haven't graded yet, I bet you I'm going to look on them, and I'm going to see a lot of people that would have put angle C here. You can't do that. And then we all freaked out. Oh, how do I name it? I can't name it. Sure you can. You name it as if you were to draw this angle. If I was to draw the angle I'm referring to, I would start at A, I would go to C, and then I'd go to what? D. That's how I have to name this. So I would have to say it's congruent to angle A, C, and then D. D. You can't say B, because then if I say B, I'm going to have to go this way. Okay, A, then to the what? Vertex, and then just exactly how I draw it. Trace it with your finger. Now, I could have also called this angle BCD, because I would still draw the same angle, would I not? Yeah. Or I could call it angle DCB or DCA. But I cannot call that angle C. And I want to make a big point of that because there were so many people making a mistake on that. Okay? Now let's go down here, find each measure. They want the measure of angle ABC, A to B to C, so this is what they want. What is it equal to? 60 degrees. Because why? The isosceles triangle theorem says that if this side is congruent to this side, then this angle is congruent to what? Now, as you would figure out that this is 60, what does this then have to be? What does it mean this is? That's congruent as well too, isn't it? We know that it's equilateral. Anytime all the angles are 60, it's an equilateral triangle. Now, this is 40 degrees. They want us to find measure of angle EDF. That angle right there. This is what they want us to find. Normally, I wouldn't be able to find this. But what have they done here? They have said this is congruent to what? So what does that mean about these angles then? They have to be congruent. No, they're not all 40. Hey, again, Everyone needs to remember this. What does it mean? Because this side's congruent to this side means this angle is congruent to what? This angle, the isosceles triangle theorem. That's the main theme in this section. That in any triangle, if the side is congruent, the opposite angle is congruent. So if this is 40, there's 140 degrees left for those two angles, is there not? And if they're congruent, that means one has to be 70 and the other has to be what? I just divide that by 2, don't I? So the answer here is what? 70 degrees. Now, let's look at number 7. Number 7, find the value of each variable. If these two angles are congruent, does that tell me anything about this triangle? What are those? What do you mean?
Those legs are equal.
Okay, if these two angles are congruent, then these two sides have to be what? So, whatever their measures are equal. So, what's equal here? 2x plus 4 equals what? Find the value of each variable. Just a matter of solving this equation, isn't it? Those of you that like to have the x's on the left, you could do this. You get a negative x is equal to a what? Negative 14. So what's x equal to? Now this one over here. What are we going to do here? We're going to have to know more than just stuff from this section. First of all, this section is about the isosceles triangle theorem, basically, isn't it? If that's congruent to that, what do I know about these two angles here? They're congruent. However, there's a couple ways you could do this. If you know this is 2x plus 3, and this is, what's this got to be? What do I know about all the angles inside a triangle? They equal 180 degrees. And I know that's 90 because of that square right there. So I could do 2x plus 3 plus another what? 2x plus 3 plus what? Would have to equal what? Is that correct? Now, some of you may have saw an easier way, and I'll do that right quick. Maybe not easier, just a little bit smaller equation. What do you get here? You get 4x plus 96, is that correct?
Yep.
Equal to 180. Subtract 96. 4x is equal to, divide by 4, what do you get as an answer? $21. Now, the other thing you could have done, okay, if this is 90, right? What's left for both of these angles to be? There's 90 degrees left out of 180, isn't there? And since they're congruent, you know that this one's got to be what? 45 degrees, and this one's got to be what? So you could have said 2x plus 3 equals what? You would have got the same answer. Either way is wonderful. This is probably different than what's on Canvas. Your assignment, numbers 1 through 7, 9 through 22. Write problems, draw figures, show all steps and work. Due at the end of the hour tomorrow. Okay? Now, there's one proof there, only one. Guys, I had better see these figures drawn and labeled. Better you write the problems, you can abbreviate, and you better show me all steps and work. Guys, if you don't show me an equation on 19 through 22 and 5 and 6, probably the best grade you'll be able to make on this assignment is a 6 out of 10 or 5 out of 10 if you don't show the work for those. Period. They're going to take you twice as long as everything else. And on number 9, for instance, it's a pretty, I would say, AB is congruent to AE. Name 2 congruent angles. That's how I'd write the problem on number 9. It says if A, it's congruent to that, name 2 congruent angles. So you can abbreviate that to where it just takes a second. Do a good job drawing that picture. You only have one picture off to the side. Okay? Also, guys, you got to start grading correcting at least the odds. You got to do that at home. Or, you are going to have some time to work on this tomorrow. But for the most time, you're not going to.